Hello guys, welcome back to another lesson, and also I want to use this opportunity to wish you all a happy new year. Now today we are going to be looking at a feature in ETAP which is called configuration manager. This allows us to use different configurations that enable different settings, different operation modes for a network or system. Now if you're yet to subscribe, smash that subscribe button and also turn on the notification bell so you get notified immediately I upload a new video. Now, having explained what configurations are, we are going to use the example of the test which I gave you guys. Congratulations to all those who actually participated in the test, and now we are going to be putting it into work. So this is the one line diagram, and this is the composite network. Now for those of you that were asking me about the parameters for the impedance, this is it. This is the rating. So now back to today's lesson, which is on configurations. Now this here is the configuration manager, which can be used to easily access breakers and choose whether they should be opened or closed. Basically, configurations are basically for breakers, switches, fuses, and all that, isolators and the rest. Now, how to create configurations. Today we'll be looking at basic 5 configurations for this network, and the first one will be for transformer 2 down, that's D2 down. First of all, you go to the multi-dimensional database. We can see configurations. Is when you open it, it will be like this, just the name of the project. Then you just double click on it and you see configurations. You see, after seeing configurations, you see presentations and study cases. Then after clicking on the configurations, you see status. Now this status is what gives us the number of configurations. Currently it's at 1 because it's only one configuration we have, which is normal, the original design of the network. So in order to create a new one, you right click, create new. Remember I said the first one we'll be looking at will be T2 down. So as you can see now, we have 2 configurations, normal and normal 1. All we have to do is change the name by double clicking on the normal 1, change the name to T2 down. That is transformer 2 down. Okay, and now one thing you should notice when creating a configuration is getting exactly the same network and duplicating it, giving you access to try out different modes for the configuration. Now I'll be using load flow analysis for the purpose of this lesson because basically it's what we are looking at, and it gives me an easier way to operate with breakers, because when the auto run is on for load flow analysis, you can actually just double click on a breaker and it will open, or you double click and it will close. Now remember, normal configuration, when you create a configuration, now after duplicating the network, the new configuration in which you have created, in this case which is T2 down, in the new configuration all breakers that were opened will be closed. All breakers will generally be closed. If we observe from the normal configuration, we can see that CB3 and this CB4, they are both opened. But when we move to T2 down, we can see that the breaker is closed. So all we have to do is to open it and then remember the second breaker, CB3, open it. Although you can leave it closed depending on the configuration you want. Now remember the name of this configuration is T2 down, that is transformer 2 down. How to achieve that is just to open the breakers associated with transformer 2, which is this. Now once you open this stop run, obviously every other thing here becomes open rather, and there will be no continuity here. Now if this breaker was closed, then it will flow, the power will flow from here and still flow through these buses. But due to the fact that it's opened, this part is completely isolated from the network. Same thing applies here. Like I said, we'll be treating only 5 major configurations. Now what we have to do for the next configuration, we'll be looking at T3 down. Create a new configuration. Number 1, we change the name T3 down. And then all we have to do is come here and then come back so it comes up in the configuration status. And remember, CB3 and CB4 are closed. So coming to T3 down, we can see that the breakers have opened again. So we close them. The breakers have closed, so we have to open them. Open them. And now remember, it says T3 down. Sorry, I'm changing the mode again. T3 down, which means transformer 3 down. Now where is transformer 3? This is transformer 3. So opening the breakers at transformer 3 will result in this, isolating this part of the network. Now this helps in a case, maybe let's say these motors, you want these motors to run while this one shouldn't be operational. It's not at every point in time you will have a full operation in the network. Sometimes, like in your house, it's not at every point in time you switch on all the lights in your house. Sometimes if you're not in use of it, you switch them off. That is just the same pattern of this network. Now if this part of the network is not in use, the breakers can be opened and the system will still run. That is the aim of this. And in the case of fault, for fault analysis, let's assume now transformer 3 is having fault, we can isolate it while the other part of the system is still working. That is the basic aim of configurations. So as you can see now, T3 is isolated, this part of the network is isolated. So next configuration we'll be looking at will be T4 down, that is transformer 4. Okay, I'll try to be fast to reduce the time for the video. Like I said, after creating configurations, we see that the breakers are all closed, so we have to open the CB3 and CB4 for T4 down. So we open and we open. Now remember, T4 down means isolating T4 transformer 4 from the network, so that's simply to open this breaker associated with transformer 4. Once you open it, you see that this part of the network is now isolated. But remember, there are also two breakers associated. This is also associated with it, CB6, because from here is where it comes. So once T4 is isolated, this is how the network will be. I'm trying to be fast. then the next one to create a new one, T5 down. T5 down. Now that's for transformer 5. Remember, these breakers will be open, CB3 and CB4. So for T5 down, that is transformer 5, we go to transformer 5 and open the breakers associated with transformer 5. So this and this. So we have this. Now the next and the final one is for tie breakers. Remember the tie breakers we left? Now name tie breakers closed. Okay, we're out of space, so tie breakers closed. Let's just assume there's a close there. So creating this configuration now, basically someone asked me what are tie breakers. Tie breakers are simply bus couplers, or a breaker, a circuit breaker isolator that connects two buses together like this. We can see that bus 11 and bus 9 are connected together by the use of a breaker, and also here CB3 connects bus 5 and bus 6 together. Now this configuration says open tie, closed tie breakers rather. So the tie breakers are naturally closed. All breakers are closed once a configuration is made. So that's why no need to change anything here. Now from this we can just simply analyze everything. These are all our configurations. Now this is the normal one. I put the load flow on auto run. This is the normal configuration which we designed. This is it. And now we can see what happens if there's a fault on T2. Now we've isolated T2 from the system. T2 is isolated. Or maybe there's no fault on T2, there's a fault on T3. We can still check and we isolate it. Now, as we can see, T3 isolation caused another isolation in T4. But if we should close this breaker now, everything will run, but they are criticals. Some buses are marginal. Now, that can be another configuration. So you can just mess around with it, learn how to create different configurations. You can actually create any number of configurations you wish. It's actually infinite. So just keep trying different configurations and give me your feedback. Thank you.